Okay, so my 4th and 5th graders reviewed their racetrack method for finding factor pairs, and I'll review that in just a second if you haven't watched the other video, or you could go watch the other video. But now we're asking you guys to find factor pairs of bigger numbers, so like 3-digit stuff, right? But now we're kind of running into a problem where some of the ending factor pairs are a little farther apart and you're still having to check a lot of numbers. Okay, so if you don't know what I mean, like I'll review the basic one I shared. So, okay, so let's say you're asked to find factors of 42. So now what we do is we're going to start off with listing 1 and itself first, because we know that 1 and itself is always going to be a factor pair of that number. So we know that since it's even, 2 is going to divide it. 7 gives me 42. So right now I think you guys can see why I chose this number. So we have 6 and 7 as a factor pair. So now in the other video, or when we first learned this in like 4th grade, we said, well, once these factor pairs become 2 apart, 1 apart, or the same thing, we can stop. So it helps us to really save time on this, because now we're not actually having to check anything on this side, right, that we missed along the way. Like we don't have to check 8, we don't have to check 9, 10, 11. We don't have to check like things over here. Like we don't have to check if 15 fits in there. We don't have to check if 16 fits in there. We've already kind of covered that. So now the racetrack thing, that name comes from, you start at 1, vroom vroom, drive around the racetrack. All right, so now we just list this from 1 around that racetrack in that order. So the factors of 42 are going to be 1, 2, 3, 6, 7, 14, 21, and 42. And the cool thing about this is, again, go watch the other video, because this is all review, right? But now it's already in numerical order, because usually they want us to list this in numerical order, so now we don't have to think about that, which is kind of cool. All right, now let's talk about what happens when these factor pairs that we actually end on are not that close. Do we need to keep checking? There's a couple things you can remember about this number, the 7 number, not 7, but like the number in this position, that's gonna help us save some time, because we don't want to be checking all the numbers to see if it divides into it, like during an assessment. That's not gonna waste time. So here we go. Okay, we're back. So now we want to find factor pairs, or just list the factors of 93. Check it out. So we know that we start with, well, here's 93, right? And we start with 1 and itself. So 1 times 93 gives me 93. We know that that's going to be on our factors list. Great. Okay, 2's not going to work. It's not an even number. So we're going to skip 2. Now we check 3, all right? Well, we know that it's 3 times, why is this so hard? 31, right? And then up until now, right, we're like, okay, so now we keep going till the factor pairs become 2 or less. Great. So now, Mr. Tino, you want me to check 4, 5, 6, 7, 8, 9, 10, all the way up to like 31. No, don't do that. So in cases like this, one thing you have to remember is, if this second number, the bigger number in your factor pair, becomes a prime number, you can stop. Yeah, like, sorry I didn't teach you that earlier. Well, sorry, I'm not sorry, because I'm teaching you like in order. So first we learned about the racetrack method, and now we have these cases where now we're asking you to find factor pairs of numbers that are a little bit bigger. And this happens a lot, and a lot of students are like, your method, like, it's junk and it doesn't work, because now I've got to check all this stuff anyway. No, because you weren't paying attention in class when I said when this becomes prime, you can stop. It doesn't have a lot to do with if this first number is prime, the smaller one. It's only when this bigger number becomes prime. Remember that. So now I'm done, because 3 times 31, well, 31's prime if you studied your primes up to 100 like we did in class. So now we just, again, go from 1 and we vroom vroom around the racetrack. So our factors of 93 are going to be 1, 3, 31, 93. Done. Cool. Okay, so let me give you another example. Okay, so now it asks us to find I'm asking you, because I'm coming up with these examples. But anyway, so we're asked to find factor pairs of 170. Okay, it's actually going to be faster than you might think. So we know we start with 1 and itself. So 1 divisibility because it ends in a 0. Well, 10 times 17. And then here the students go, Mr. Tino, do I need to check 11, 12, 13, 14, 15? No, you don't, because this ended up being a prime. You're done. So here, start here. Boom, 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 boom. Okay, and here are your factors of 170, 170. There's my factors list, right? Here it is. The point of this is once this number on this side, the larger factor, when we make our factor pairs in this method that we already talked about in the first video, once this number becomes prime, you can stop wasting time. Okay, I will show you another situation, so edit. So I listed 2 situations here where this racetrack is done. I'm just gonna start off saying that we're done with this. And here's how you can check, right? I said, well, when this number becomes prime, you can stop. Okay, here's a couple situations where that number over here on the right side didn't end up being a prime. But I know I can stop here. And here's the trick here, right? It's just that this 15, think about it. Since 15 is 3 times 5, I've already accounted for those factors here. So once I get to a point where, yeah, it's not prime, and yeah, like, I mean, you could, it's not that far apart. Like, you could check 8, 9, 10, 11, 12, blah, blah, okay? But right now, I practiced this enough that I know that, oh, okay, well, 15 is 3 times 5. I've already checked those factors. I don't need to keep going. You don't want to stop, for example, at 21. I'll show you this just real quick. You don't want to stop at 21 because, think about it, 21 has factors of, besides 1 and 21, it has factors of 3 times 7. At this stage in the game, when you listed 5 times 21, you've checked 3, but you haven't checked 7 yet. So you have to keep going. So you know that 7's gonna end up being on this list later on down the line when you're at this step. I know that's a lot, and maybe I can make a separate video on just this portion of the factor pair thing. Factor pairs are pretty fascinating in that there's a lot we can talk about when it comes to methods and strategies to go about it. Because if you don't have a strategy going into finding factor pairs or listing factors of a number, it's going to take you a long time to have to check every single number. Here's the other example, 98, right? 1 times 98, 2 times 49. We can't stop here, right? 49 is not prime, we can't stop. It has a factor of 7 in there. We haven't gotten there yet, so we can't stop there. So we're gonna keep going. Okay, 3, 4, 5, 6 didn't work, but 7 works in this case. And if you do the long division, it's 14. Here's another case. I know I can stop here because 14, besides 1 and 14, has factors only 2 times 7. Which means, hey, I already accounted for those 2 factors here, which means I can stop. I know that was a lot, and this last portion I would say is pretty advanced. So one more example. Okay, last one I want to show you. 196 is an interesting number. If you know your squares pretty well, you know right away that this is actually a square number. Might not be able to recognize that. So here we go, finding factor pairs. We did all of this, right? Okay, so here we ended up with, because we can check this, it's not too bad. Okay, getting up to here, great, 7 times 28, we found that out, awesome. 28 is composite. It means I can't stop. I gotta keep going. But my question here as a student probably would be, okay, do I need to check everything going up to 28? No. The strategy here would be, okay, like, you know how to check for 8? Just, I don't know, divide it. 9, digit sum. 10 doesn't work. 11, probably doesn't work. You can check it, but probably doesn't work. I already know that 11 doesn't work, but that'll be a different video on divisibility. 12, might have to check that. There's a trick, again, different video. Here we use the thing that I talked about earlier, which is, so 28 has several factors, right? 28 has factors of 1 and 28, 2 and 14, not 3, okay, and 4 and 7. So 28 has those factors. So here we say, well, we've already checked for these factors here. Like, we know we did 1, we've done 2, we've done 4, and we've done 7, and here's 28 itself. The only factor that's kind of hiding in here is this 14. Again, Since it's on this factors list, but we haven't checked it on the left side, we know 14 is gonna work. So then I bring in, I know 14 is gonna divide this, and what is its factor pair? Turns out this number is 14 squared, so 14 times 14 is going to give me this number. And going all the way back to the very basic racetrack method video, once these two numbers are the same, aka this is a square number, we can stop. Super awesome. I know that was a lot in this video. Watch it over and over. Yeah. There. Why am I so awkward?